Hey guys, we are live. Thank you so much for joining us today. I'm really happy to see a lot of people who have already joined, and I hope this number goes further. Welcome to Mantissa Data Science webinar. Today we have with us a very special guest, Tanaya Babtiwale. She's an ML engineer at Jio Haptik. Let me give her, I'll tell you the agenda for today, and then we can take it forward from there. I'll give a small introduction about her. And then she has a very interesting session for you, which she will take ahead. And perhaps she can take questions and answers towards the end of the session. So Tanaya Babtiwale, like I said, she's working as an ML engineer at Jio Haptik, where she works on building conversational AI systems. She has earlier interned at companies like IBM Research and Mahindra Rise, and is interested in research projects under the umbrella of conversational AI, NLP, and computational linguistics. So Tanaya, welcome to the session. Glad to have you here. And
Thanks
yeah,
so
please
much.
take it over.
Super happy to be here. I'll just share my screen. I just realized I might have dicey internet, so let me know if you lose me at any point. So, hi guys, I'm Tanaya, and today I'm here to have a conversation with you about natural language processing in the real world. Uh, Big thanks to Ahmad for having me here, and a huge thanks to all of you for taking out your precious time on a weekend to be here to listen to me talk for an hour about something that I love. So, yeah. Um, a little about me. Even though I graduated in 2020, I've been working in the field of NLP for quite a while now, which is 4+ years. I started off with natural language generation, generating cricket commentary for a startup, to information extraction from business cards at Mahindra and Mahindra. A couple of very NLP focused college projects later. I had the opportunity to um, do research with IBM Research Labs on semantic web. My research there was about interpreting implicit intents in conversation in question answering systems, and I got a chance to publish a paper on it at Coling last year, which is one of the top international conferences in natural language processing. And now I'm doing what I love full time at Haptik, a leading conversational AI company. We deal in chatbots. So without much ado, I want to move further because there's like a lot to cover. Uh, so I will start off with NLP yesterday. So NLP today is a very hotshot buzzword, and the next cool thing. But NLP research has been going on since 1950s probably. There was a time between 1966 to 1980s when people actually gave up on NLP, saying, "Oh, this is never going to happen." But since 1980s, it took pace, and there were very parallel researches going together based on semantics, knowledge graphs, and even neural networks for that matter, going parallelly. In 2008, it all came together, and we figured out we can use the same kind of word embeddings or the same kind of input for multiple different tasks together. And that is where multitask learning was born in 2008. Then we figured out that, these word embeddings, we can actually use them dense instead of sparse. So word embeddings came into the picture. Then slowly we figured out, with neural networks, they're not that difficult to train. We can actually use them today. Maybe it wasn't possible in the 1966, but right now it is. So let's use that. And so with that and Ilya Sutskever's PhD thesis, Sec2Sec and LSTM came to life. And Google replaced their 5,000 lines worth of code for their Google Assistant with just 500 lines of model code. So that was when NLP came into the picture with a bang. So this is a generic graph on the advances in NLP, the number of publications, the research that was going on. And as you can see, we've had a very linear kind of advancements towards the field since a long time now. That is till 2016. And then after 2016, as you can see in the graph, the world said, boom, let's do this. And that gets me to NLP today, which is a super rapid evolution of NLP. When transformers came into the picture in 2017 with using self attention, and then we had to use PyTorch and TensorFlow, and have a full understanding of tensors to train language models like ULMFit, BERT, XLNet. It came to a point where for 2 years straight, 60 to 70% of all the research in the top published in the top conferences all over the world had BERT in the topic. So, BERT for this use case, BERT for that use case, problems with BERT, what is great about BERT. But the problem with this was it was not available to all the masses, because not everybody has a GPU to train, these huge pre-trained models on. Hugging Face completely changed that. Hugging Face came into the picture and said, we're giving you data sets, we're giving you these models. You can implement these very heavy duty models which need absolute, huge amount of statistical and mathematical knowledge. And we're giving it to you in 5 lines of code. So, do what you want with it. So that brought in a lot of more research. And again, the big companies, the big data companies were training on bigger and bigger and bigger datas and parameters. So here's a beautiful graph by Dennis Mark, which kind of shows you that, how as the years progressed, we're increasing the amount of parameters, we're increasing the size of data set, and we're just training on it. And the SOTA that you publish today might not be SOTA in the next 3 days when someone exceeds your model's accuracy, the state of the art model's accuracy by 2%, and suddenly your model is okay, a thing of the past. And that is what happened in the past 2 years, which is still like 2019 to January 2021. As you see, it all exploded. Switch C has 1.5 trillion parameters, and that is a huge number. So along with that, so that brings us to the question, how do we implement these models in the industry? In the industry where 3 things are of the utmost importance. We have scalability, maintainability, and generalizability. So these number of models, you can't, number one, storing these models data, or even training these models as per your use case would be a huge task and a huge use of resources as well. You will need, GBs and GBs of data, and it is expensive. And in the industry, your point is to use the least amount of resources, use the least cost procedure, use to optimize on performance. So it's okay if your performance is in 98%, if it's 97% and it's saving you $1 million, right? So more about these 3 specific factors. Handling growth. So scalability comes in 2 forms. So it is also handling growing amount of resources, growing amount of use cases, business tasks, business requirements. So that is scalability in terms of your clients. And scalability also comes in terms of operating on high loads, the number of messages you cater to, number of requests you get per day, per second, and the number of documents you need to process per message, and things like that. So that scalability is very important. Then you have maintainability, where you have to maintain the same amount of accuracy throughout models. You can't say I have a better accuracy for the retail domain and maybe not so great accuracy for the finance domain. You need to maintain your absolute results throughout whatever use case you have. It needs to be client compliant. And it also needs to be maintainability in the sense that if you want to add new features, if you want to add new model, if you want to delete something that you've already written, that can be easily done, and that should be able to be easily done. um, so that also includes your code structure. uh, then generalizability. Generalizability is essentially the trade-off between catering to several client specific use cases versus thinking about what is the common thing, what is the common thread that is tying all of these different domains together, and then making sure that you don't have to implement it separately for every model. So I maintain that NLP is about building systems and not models. So NLP in the real world is far from implementing BERT on the Wikipedia dataset, because it is, as you can see here, it's a very great picture from hidden technical debt in machine learning systems. So you can see that ML code is like a really tiny part of what a whole ML system actually is, and that holds true for NLP as well. You have these various steps that also need to be taken into consideration other than just models. You have to automate your data collection and annotation. So when you mean in data collection, you need to collect data from your clients, because the data is specific to their use case. The data is has to cater to what they exactly want. You can't tell them that we have this data, you have to work with this. We have to work with their data. But at the same time, machine learning models need a huge amount of data. So you can't ask the clients for that much data because they can't give it to you. So you need to internalize a data expansion. And so data expansion is a huge part of your system. And then, as I was talking about generalizability, you need a fundamental data, which is the backbone of your entire system. Whichever client, whichever use case, there is some data that you have as a company that you can offer, and that builds your system from the ground up. So that is about data. Then you need to serve the models end to end in production. So it doesn't just mean training and validating. It means testing it with the pipeline, with the entire flow, if it's fitting into the flow, where it's fitting into the flow, how it's fitting into the flow, and then constantly monitoring it even after it has been deployed. So this constant monitoring needs a few things, such as reporting on accuracy and performance. Sure, yes, I give you this much accuracy, my speed is this much, great. But compliance, that with what the client wants, compliance with what the client needs. And another thing that has actually erupted in today's times is fairness. Your models trained should be far from bias, far from discrimination. Your model should be fair to each and every user. And you have to report on all of these things, and you have to ensure that all of these things meet a certain standard that you can actually contribute to the industry with. Then a more wider perspective is you need to maintain, you need to have an achievable goal to maintain 99.9% of uptime. So that means your models or your entire system needs to be reliable. It has to ensure that even if there was an error, my system entirely won't go down. It needs to be robust, so if there was an error and my system goes down, I can fix it without much loss of uptime. Then apart from this, the velocity. So velocity also comes twofolds. Velocity comes how quickly you can complete your client requirements and give provide them with the end to end use case, as well as velocity comes with how fast am I getting responses when I enter a message, and how fast the chatbot is replying to me in my case. So that is important. And then a hugely overlooked part of the whole system is the code quality and transparency. Your code should be of top quality. A new person entering your team needs to just see the code and be able to understand what is happening without having to go through the documentation. Your code should be self-explanatory. The code should be reviewed thoroughly before it reaches production by somebody. Code review is the most important part of the whole cycle. Um, one of my seniors actually told me that you know this code review is more difficult than writing the code itself, because you're trying to understand where the other person is coming from, you're trying to understand their line of coding, and then you're trying to find faults in them. So that takes more amount of time than coding actually takes. And then you have transparency. So transparency should be there internally, if not externally. You need to be able to debug the code and fast. You need to have great logging. You need to know what is going wrong if something is going wrong. So, you have to fix it. You don't need to keep trying multiple cases to see what is actually breaking. After all of this, though, one point that is at most important to me is data normalization. And that is essentially what I want to base today's talk on. So, coming to agenda of my talk today is need for normalization. And, it is because there's problems with real world data. As I said, you in the real world, you have no data set which is directly catering to your task. You don't have a large corpus to train on, a clean corpus to train on. There are no set rules for pre-processing, because pre-processing techniques differ use case to use case, and also pre-processing techniques differ from kind of input data to kind of input data. And right now, when we're taking in multimodal input everywhere, there are definitely no set rules for pre-processing. And most importantly, this is all real time. It's happening, and it's happening right now. So we can't take, I will think about it. Okay, this is breaking. I will think about it, and I'll think about how to fix it. No, it is happening right now, and you need to fix it right now, which is the problems with real world data. So I will be going into these in the detail for the rest of my talk. Uh, so colloquialisms. So informal phrases, expressions, idioms, culture-specific lingo is extremely prevalent. So if I am in a conversation and something's not going up according to my plan, or like what I want, so the system tells me something and I don't agree with it, and I say, I can't even. The system's not going to take it as, oh, there's something wrong with me. The system's going to take it as, I am unable to do something. And that is very wrong semantics. If I say, oh, I got 10,000 followers, does that mean 10,000 people are here right now following me, stalking me? No, it doesn't. If I go through an entire conversation and I've ordered a product, I liked it, I'm giving feedback on the product, and I say, thanks, it was rocking. What if, I mean, if you take it in the sense of a real world product and you say, oh, that product is, rock, that chair is rocking, that means there is something wrong with the product. So how do you know what are the semantics behind it? So a huge part is understanding semantics behind all of these colloquialisms. And therefore research in semantic is absolutely important, even if you're a machine learning engineer looking only at machine learning algorithms, because semantics is something that is at the root level of every language. Then you have acronyms, and most of them are officially recognized. You have World Health Organization, United Nations, United States of America. IMO, you have International Maritime Organization, which is officially recognized. But a lot of them are unofficially recognized. So if you say FAQ, ROI, PPT, everybody knows what you mean. Maybe if you say IMO, you mean International Math Olympiad, which is unofficially recognized. If I say I gave, I was writing IMO yesterday, people know what I'm talking about. But then you also have to consider extremely specific acronyms that are coming up: LOL, good game, something as long as if you know what I mean, and IMO, in my opinion. So you see how one acronym can have multiple meanings. So here it is up to you to know where you have to draw the line. So this is also entirely use case dependent. So if you have legal documents, if you are working on government data and you have those absolute specific formal letters, then it's fine if you just recognize the officially recognized acronyms, and you absolutely don't have to recognize other acronyms. But if you are having a casual conversation and you do not understand the meaning of LOL, then we have a problem. So this is a trade off massively, and you need to understand it use case to use case wise. Usually, these are these can't be learned by systems, so this needs to be maintained in like a dictionary or a database kind of structure. Then you have spelling mistakes. So there's intentional spelling mistakes, or not mistakes, intentional deviations, where you use PLS, TXT, and so you need to know what these mean. But at the same time, there is a lot of unintentional errors. You might accidentally type the adjacent character on the keyboard. You might switch the position of the characters, or there might be extra characters or less characters in what you've typed, maybe because you don't know the exact spelling, or because maybe your keyboard is faulty. It could be anything. So you cannot store all of these mistakes, because how many mistakes will you store for a simple 5 lettered or 5 word sentence? There is 3 million possibilities of how you can permutate and do combinations of different letters to see what spelling we have to look at. So a solution is Haptik has open source Spello library that is you guys can use. But what we do is use SimSpell. SimSpell is a very popular model for spelling checking, where we use a modified version of SimSpell, which actually derives from errors that occur because of the keyboard. So QWERTY errors, you mistyped, or faulty keyboard, those kinds. We integrate that with a phoneme model. So phoneme model essentially looks at wrong usage of words, but something that might be semantically correct, and thus corrects accordingly. There is also a context model, which is, in my opinion, the most important model to have. So if you have IBUR and Apple Watch, so BUR is definitely a spelling mistake. BUR can be translated to BUT but, BUS bus, BUN bun, BUY buy. So out of all of these spellings, getting the correct, absolutely correct spelling is important. And if I'm looking at just the QWERTY errors, my SimSpell model will definitely translate it to BUT, because R and T are next to each other. But that's where buy kind of comes in. The I buy an Apple Watch makes more sense than I bought an Apple Watch, or I bus an Apple Watch. So so this is kind of the model that we have and are using. The open source version is also available for Hindi language if you guys want to look at it. Then this multilinguality. This is a topic that is absolutely closest to me. I mean, my undergraduate thesis was on bringing advances in NLP to the Marathi language specifically, because I feel like there's so many languages. There's more Marathi speakers than there's Italian speakers, but the kind of research that's been happening for the Italian language is a lot as compared to what's happening for Indic languages, not just Marathi, but Odia, Punjabi, etc. So this is a use case very close to my heart. We have very different things even when we consider a lot of languages. We have choice of scripts. Not everything is Latin based. We have code mixing. So we have kind of use cases in English, Spanglish, and things like that. and with there's intrasentential and so intrasentential is mixing of words from multiple languages in the same utterance as in the second example. And we also have semantic translation. So for example, the use case that I've given here, um, Geo, if this sentence you're translating into English, geo means to live. So the translation would not necessarily make sense because geo is actually a domain word. Geo is something I'm referring to my company. So, those kind of things also have to be taken into consideration domain wise. So, yeah, we support around 19 languages at Haptik. Context. Context is super important. I say that a context, a system is naturally stateless. It does not have context. But a chatbot without context is basically like answering from an FAQ sheet with just very good search techniques and search mechanisms. So context is something very important. So what is context exactly? So as you can see at the example at the left, so I in the first message I'm asking something about Tanaya. Second message is kind of knowing that like with regards to the previous message, I am talking about her. I'm talking about Tanaya, and then I'm asking and works at. If you ask me and works at very randomly, I wouldn't know, right? That what am I talking about? But this keeps into mind the context. That, okay, we're talking about Tanaya, so she works at Haptik. So that is context. We at Haptik go a step further, and we use probing as a mechanism as well. With probing, as you can see, if there is no context involved, if I just say check premium directly and I don't have anything to go with, there can be multiple associations of that with like multiple different contexts. So we provide the context and say, oh, is that what you mean? What do you want? And then if that is something that you want, the entities that are required for it need to be asked. So that is also taken from context. Coming to data. So acquiring data, processing data, tagging data, validating data, and the cycle continues in circles on and on and on. I need more data. I improved my model. Now I need more data. So this is a never-ending cycle. So what is usually done, and what we also do at Haptik, is we use data augmentation methods. So I've listed down some of the generally used data augmentation methodologies. So I can just explain that with an example. If I say I don't want a burger, I add I do not want burger to the same database, that is increasing the number of data points I have. Sentence distortion, I jumble up the words. Adding non-diluting noise, I add uh, tokens that are not that do not really change the intent of the whole sentence. But we also need to use negative augmentations in these cases. So if I say I don't want Pizza Hut burger with jalapeno toppings and cost is high, then I am adding so much noise to it that I am mixing up my intent. So am I talking about Pizza Hut? Am I talking about burgers, jalapenos? Who knows? And it is raining. So, I mean, that's gibberish. That's not related to anything. So I do not want to consider these examples. Hence, these are added as negative augmentations. Also masking true intent. So if I'm just replacing a few tokens with synonyms or something, uh, so if I say if I don't want burger is in my training data, then I don't want pizza will also probably be selected as a positive data point, because I mean it is so close to the sentence in nature, because there's only one word is different. So we add these kind of things by masking true intents to the negative augmentation, so that we don't overfit on certain kind of statements. Uh, ambiguity. Ambiguity is very prone even in our general human conversations, even when we speak, usually we need to ask for clarifications, because otherwise miscommunication is something that is prevalent. So here's kind of a poll. So if I say, this is like a real world example. This is something that we actually absolutely got. Someone said, I want to terminate current SIM, only 1 year plan, and switch to iPhone 12 Pro plan. I was wondering about the termination cost. So there are so many intents packed here. It is very difficult to know what it is I am actually talking about. So is user looking to stop the plan? Yes. Is user looking for termination cost? Yes. Is user looking to switch? Yes. But with all of these, there's different contexts, or rather different procedures that I want to follow. So if the user is looking to stop the plan, I ask them to maybe fill a registration form to stop the plan. If they're just asking for the cost, I just give them the cost. It all also depends on what plan we currently have. So apart from the sentences in bold, the non-bold sentences essentially are relative terms. So usually when I want to switch to a new plan, if I want to switch to an iPhone 12 Pro plan, I might be looking for a promo code. So that is also something that the system might suggest. And then is user looking to buy a new phone because they're going to iPhone 12. So yeah, this is where ambiguity is jam packed. We are haptic, we use disambiguation techniques, which, so one is confirmation. If we're confused between two different intents, then we ask the user itself, because we don't want miscommunication. Did you mean this or did you mean that? And the second is clarification. So how much 17 kg is then split into, tell me more. What do you exactly mean? Because, can you please rephrase what you're trying to say? So that kind of solves a lot of ambiguation issues that usually come up when you are trying to converse. So these are the major problems that you get with real world data, and a brief about how you can go about solving them. So I want to reiterate back to this slide that systems is the building the whole system is the most important thing. Behind every machine learning researcher, behind every machine learning engineer, for a successful tool, you also need a great DevOps guy. You need a great DevOps team behind you, building all of these architectures, and because that is important. That is what will help you scale. And it's not just how high you can take the accuracy. So I will give you guys a minute to actually look at, what all is necessary apart from the ML code, because this image is really, really important. So yeah, uh, so I would like to end my talk with, the kind of tech stack that we use at Haptic, because picking the right tools is absolutely 100% important. Uh, we also use Hugging Face, because Hugging Face is a lifesaver, and we use a few things from Fast AI, OpenAI. Uh, we tweak these models under the hood for performance. We don't obviously directly use entire models. We use an ensembling technique, which is kind of gets together all possible models we build, and we have like a permutation combination between which to pick when, it depends on the conditional use cases. And so yeah, this is I think the most important things that are in my ML tech stack today. And this tech stack is actually handled over 4 billion conversations. So I am pretty confident with this. Uh, so I will now go to questions, because that was my talk.
Thanks, Tanaya, for that wonderful talk. Do you want me to take the questions and get them on stage?
Sure, yeah.
Okay, so let me sort by the latest one. So let me show that on stage. Sasidhar asks, any suggestions working with non-English words like company names?
So it depends on what kind of company names it is that you're looking at. So if you only want companies that are under your uh, kind of umbrella, uh, then you can have like a domain glossary very specific to the company. Otherwise, there was a way that I had used when I was working at Mahindra, because for business cards specifically. So since business cards had a lot of companies and none of these companies were in data set, and we had to kind of recognize that this is the company out of all of these words that are available on this business card. So we kind of extracted like a lot of company sounding data which had a lot of ink, ltd and all, and we trained an XGBoost model on it, and it seemed to work pretty well for us at that point in time. So of course this can be explored a lot more, this can be tweaked and enhanced a lot more, but yeah, that is one way we can go about it.
Cool, thank you. I hope that answers the question. I'll take the next one. Next one says, can you talk more about the context, the implementation part of it?
Sure. Yeah. So the main thing about context is a memory. So you need to have a short-term memory in place for that, and so to store basic data that is relevant only to that conversation. You also have to make a decision on whether or not is the past three conversations enough for context. Do I need more? Do I need less? Because more can actually, storing more context is also harmful in the way that it wastes resources, and storing more context is also harmful in the way that it can skew your intent detection or entity recognition later on. So what you can have is, so Rasa has this amazing system for context maintaining, which you have slots for entities, and you kind of expect the user to fill in these slots. So if I have, about suppose I have five different entities related to a node, specific node, and I have the user has only provided you with three of those entities. Then you probe for two more entities, and you keep in mind, or like rather, you keep in the system that these two entities need to be filled. So you need to be keep looking out for these two in context of the next conversation that will come across. I hope that answers your question.
Okay, let me move that as answered. This is my comment. I'm just going to take that as answered. Amit asks, can you please share the PPT? I'm guessing you can.
Sure, yeah.
Okay. Cyrus asks, you've not touched on stemming or lemmatization. Do you recommend using that?
So I kind of based my talk about, I did not go into specific pre-processing techniques like, stop word removal, stemming, lemmatization, what to work, because that is like, as I mentioned, that is a very small part of what we do in our day-to-day life. What we do on a bigger scale in the industry is look at user problems and try to solve specifically user problems. Now, how you solve them in is like a very little bits is stemming and lemmatization. So those are very small kind of things as compared to the big picture.
But I've also seen a few things. I'm not sure on stemming or lemmatization, but for example, stop word removal, right? And
Right.
particularly punctuation removal. So Jeremy Howard of Fast AI sometimes says that it's better that you don't remove them and then you train your models keeping them in.
Exactly. So it actually depends on your use case. So suppose you have dependency passing in your use case. That is when you need those stop words, right? Because she is a girl, I am a boy. That kind of helps in the relationship mapping. So if you remove is and am, then I, and so that will kind of skew your data. But if you're looking at a use case which is very intent detection or text classification specific, then you will probably not want to consider those stop words. So again, that is a very use case to use case kind of pre-processing.
Got it. Yeah. So perhaps Cyrus, like Tanaya said, it's also depending on the use case. So stemming or lemmatization could be done if your use case requires it. Okay. Next question is this one. Does Haptik use Rasa also?
At this point, we do not, because Rasa has like this very specific architecture in terms of everything. It has like very specific input formats. You have to the kind of intents that you have to give it, and so Rasa is a whole full-fledged system itself. So making tweaks in that, making differences in that is according to what we want is very difficult as compared to building it from scratch as we've done at this point.
Are we done? I
Yeah.
thought you got stuck in between.
Oh, I'm sorry.
No problem.
Yeah.
I'm just going to mark this as answered. Um, any techniques that have worked with really imbalanced classes? Shashidhar asked.
So really, so SVMs, machine learning statistically side SVMs tend to work really well with imbalanced data, but also data augmentation, as I mentioned, is like a very great way of stratifying your data, and of course stratifying your data while training and validation sets. That's a huge thing also, and along with that, data you can augment one's kind of a data to actually give out uh, more accurate answers per se.
AR asks, what is parameter with respect to Hugging Face model? I mean, I think the parameter slide in general. So maybe.
Okay. So the parameters used are basically the kind of weights that the model uses, the kind of the features it takes into consideration, the number of features it takes into consideration, and those kind of things. And Hugging Face is not its own model. Hugging Face is more like a repository of models. Hugging Face lets you use transformers easily. Hugging Face lets you use I think they have like a demonstration with GPT-2 as well. I have that linked in my slide, so if we still have time towards the end, I can show that.
Okay. We have this question. What's your favorite entity extractor tool? Is it feasible to build entity extractor from scratch?
So I don't really have an entity extractor tool that I can recommend, because I've majorly used, I've built entity extraction from scratch because it is easier that way, because you have the control over what kind of entities you want to extract and how you want to extract them. So this again is very use case to use case specific. Like if I am doing like an NER, named entity recognition thing, if I'm using date or email extraction, so then I have like very set regex, methods for that, and I don't really need to use a tool to extract date and time entity. And regex is actually like one of the most powerful tools ever. Like I love regex. Like people, there can be huge models, huge advances, and I might still go back to regex at some point to use something. So but apart from that, if you have very specific entities in mind, if you want to extract, say, invoice total from like a documentation or something like that, then it's definitely good to look at the kind of data that you have, the kind of format that your data input has, and go from there.
Okay. I think this question has become redundant now. but I'm just going to mark it as answered. There's a last question. Can you give inputs on how attention vectors work?
Sure. So attention is was basically first used for machine translation. So you have uh, uh, an entire matrix. You have, your rows are probably a token for one language, and your uh, columns are tokens for another language, and you kind of map them together. So which word comes in, the weight of one, the probability that one word in English exists in the sentence versus it exists in the French translated sentence of it. So it's a matrix like that, and it kind of so I mean, when you have a lot of data points, it the probabilities keep increasing, and thus machine translation, majorly attention by itself is used for machine translation. So it can easily map one word from one language to a word from another language. But in, with BERT and, transformers coming in, self attention is become like the next big thing. So self attention, you have like a symmetric matrix where you have your rows are also your tokens, and your columns are also your tokens, and it's kind of mapping relationships between the tokens itself. So if you have a sentence, and you are not just looking at the word before it or the word after it, you're looking at all of the sentences, and you're looking at how they relate to one another on a much bigger level. I hope that answers your question.
Okay. Okay, yet another last question. Which ML architecture is suitable for building NER from scratch, neural network?
NER from scratch. So not LSTM, because you don't really. I mean, LSTM is kind of a neural network. You don't really require. LSTM is majorly used when you want to. It's long short-term memory, right? So you need to keep the previous word in mind for this for the next word in mind. So NER usually doesn't follow those kind of rules specifically. So for in a more architectural point of view, both, you shouldn't be using exactly neural networks only to extract entities. You should have very well trained on, what kind of dependencies exist, and what entities are dependent on other entities. You need to take into consideration the semantics, etc. And thus I personally wouldn't recommend LSTM for that. So that answers your question.
Okay. Okay, this is going to be the last question. I hope. How do you deal with Unicode characters in the data? Leave them or clean them as part of pre-processing?
So at Haptik, we also consider, like, we have like a lot of languages which use Unicode characters. We have Hindi, Marathi, Tamil, Telugu, Kannada, and a lot of languages that are not Latin characters focused. So we leave them on, but you, I mean, if you're you want to clear Unicode data such as maybe emojis and text. So I personally am against cleaning out a lot of things, because every little thing in the sentence, I believe, carries some kind of meaning. So if you have like an emoji, it is absolutely telling you the sentiment of the whole sentence. So I would choose to leave it on. But then again, so if it skews your data, or you have too much of it or too less of it, then it is always great to clean them.
I've also seen a few techniques where you encode the meaning of the emoji itself, right? You translate
Right.
that to English
Right.
word and then you use that.
Right.
I
But
don't
I
know.
mean, those techniques are great from a research perspective, I feel personally. But in industry, it takes up a lot of space. It takes up a lot of resources to be doing that. It might slow you down. It might slow down the pipeline. At any given point, the first thing that you should be thinking about is how can I optimize this system? How can I do this in less time, less resources, more speed?
Okay. I think we've come to the end of question and answers. Tanaya, do you have anything else to present today, or is you said you would show
Oh
something?
yeah. So I can show. Am I still presenting? Let me go to that slide. So I really glossed over the amazing advances that have been going on, right, in the field, because so even though I said that it is not feasible to actually keep changing your models, it is definitely you need to keep up with the trends, because they might tell you like a lot of things and lot of activity that is going on. So GPT models were like this amazing, great source by OpenAI, which they trained on huge amount of data, and the GPT-3 is actually a human-like conversation. So I can show you a Guardian article that, let's see, uh, so this Guardian article is apparently written by an AI. So you can go through that. Uh, Other than that, whoops. Yeah, there's a GPT-2 demo. Oh. Okay, so this essentially writes with transformers. Um, I have, where is it? So I was trying this out yesterday and came across this.
I think you can just start typing
Can you see
and
my screen?
tab. Yeah. Oh, you have.
Yeah. Okay. So yeah. So if I type this sentence and I trigger autocomplete, uh, usually doesn't take this long, but okay. But, I mean, you guys can definitely try out with some stuff.
Yeah. So staying true to the law of demos.
Yes. So, I mean, this kind of completes your sentences for you, and this is actually pretty well in context if you read the whole input and compare it to the output, which is as good as like if I were to probably type it out. So this is just the GPT-2, and GPT-2 is not even close to the performances of GPT-3. GPT-3 is doing absolutely wonderful things in terms of coding, and so it's completing code for you. It's writing poetry. It's writing essays. It's writing news articles. So yeah, that is what I wanted to show, and it's pretty exciting.
Yeah, we can all see the excitement on your face. So,
Yeah.
thank you so much for that wonderful talk. It was really great having you. Lots of learning, I'm sure, for me and for everyone who joined us today. I can already see a few comments, a few messages. People are like, they really appreciated the session. So thank you so much. We
Thank
will
you,
be
all
back
of you.
with yet another. Okay, maybe final words from your side. Yeah.
No, I'm just like, thanks for being here. Thanks for hearing me out. Because this is something I can talk about for hours and hours at the end. So, thank you for having me.
Yeah, thank you for packing so much information in one session of about 1 hour, which is good. Which is always a very difficult job. So thank you for doing that. Yeah, we'll be back with yet another session next month. So please do stay tuned with Mantissa Data Science webinars. If you are not on the Telegram or WhatsApp group, I can send you the